Hello everyone, in this video we're going to talk about some properties of rational exponents. So in Algebra 1 you probably learned about properties of exponents or laws of exponents, and in my Algebra 1 class we also learned about that as well. So I have a video on that, I will link that in the cards right now. We are essentially talking about the same 7 rules that are in that video, but we're applying them to when we have rational or fractional exponents. So we started off this unit in Algebra 2 talking about what rational exponents are, how to evaluate them, and so I'll post a link to that video in the cards right now as well. So let's jump right in. We're going to talk about our first property called the product of powers. So they did a pretty good job naming these because the name sounds like what we should do or what it looks like. So in black we have the name of the property, in white we have basically the algebraic example with just variables, and then in yellow we're actually going to do an example together. So product of powers tells us that we have the same base here. We are multiplying. So what can we do with the exponents? We can add them, okay? So in our example, we have 5 to the 1/2 times 5 to the 3/2. So key there is we have the same base. So we're going to keep that base, and we're going to add these exponents. This is going to be 1/2 plus 3/2. Okay, so 1/2 plus 3/2, that's just going to be 4/2. 4 divided by 2 is 2. So we get 5 squared, which is 25. Okay, so that's how we can apply the product of powers property. All right, property number 2, we have power of a power property. So once again, this would be like a to the m raised to another power outside the parentheses. So what are we going to do with these two powers? We are going to multiply them. Okay, so we're going to take the product of the power. So sometimes I like to refer to this property as PPP, power product. Okay. All right, so here we have 3 to the 5/2 raised to the second power. So this is going to become 3 to the 5/2 times 2. Well, 5 over 2 times 2, those 2's would cancel, so we get 3 to the 5th, and we can evaluate that as 243. Okay. All right, property number 3, power of a product. So once again, we have a product, a times b, and we're going to raise it to a power. So this is essentially very similar to a distributive property. We're going to give this exponent to both terms that are being multiplied, or if we had more than 2 terms being multiplied, we're going to give that exponent to every term inside those parentheses. So our example, we have 16 times 9 raised to the 1/2 power. So we could do 16 times 9 and get that answer and then raise it to the 1/2 power. But applying this property, this can become 16 to the 1/2 times 9 to the 1/2. Well, we know that 16 to the 1/2 is the same as the square root of 16, and 9 to the 1/2 is the same as the square root of 9. Square root of 16 we know to be 4, and the square root of 9 we know to be 3. So 4 times 3 gives us a final solution of 12. Okay. All right, property number 4, negative exponents. So our algebra here, we have a to the negative m is equal to 1 over a to the m. And now for the rest of these properties, we're going to have to get into some stipulations. We're going to say, hey, a can't be 0 here because we can't divide by 0. So essentially with a negative exponent, we're just going to take the reciprocal of the base. So a becomes 1 over a. And then we're going to take our exponent and it's going to become positive. So our example, 36 to the negative 1/2. So this is going to become 1 over 36. So that's me taking the reciprocal of my base, which is 36. And now instead of negative 1/2, we're going to have a positive 1/2. And that exponent is going to stay with my 36 as I move it to the denominator. So now we know 36 to the 1/2 to be the square root of 36, which we know to be 6. So our answer there would be 1/6. Okay, that's the negative exponent property. All right, our next one is the 0 exponent, my favorite, super easy. We're going to say anything to the 0 power is 1, okay? So we see a to the 0 is equal to 1. So in this case, 365 to the 0 would be 1. Now, let me give you 2 bonus examples here. Let's say we had negative 5 to the 0 power like that in parentheses. So we would read that as negative 5 to the 0. Anything to the 0 power is 1, so that's still 1. But what if we had something written like this? Okay, now we don't have parentheses, so we actually read that a little bit differently, and that's going to affect our answer. This tells me I want to find the opposite of 5 to the 0. Well, anything to the 0 is 1, so 5 to the 0 is 1. What's the opposite of 1? It is actually -1. So this example right here is kind of the only time that we're going to get something other than 1, and that's just because we're not really taking the negative number to the 0 power. We're finding the opposite of the number that's being raised to the 0 power, and that's going to be -1. Okay. Property number 6, quotient of powers. So we have a to the m divided by a to the n. So once again, we have the same base. So this is very similar to product of powers, where we had the same base, so we added the exponents. In this case, we have the same base, we are dividing, so we are going to subtract the exponents. So property 1 and 6, I kind of like to put together as an acronym called MADS. MADS reminds me what to do when my bases are the same. If it is a multiplication problem, I'm going to add my exponents. That was property number 1. If it's a division problem and my exponents or my bases are the same, I'm going to keep that base and I'm going to subtract my exponents, which is property number 6 that we see right here. So our example is 4 to the 5 halves divided by 4 to the 1 half. So we could write this as 4 to the 5 halves minus 1 half. Okay. So 5 halves minus 1 half, that's going to give us 4 to the 4 halves, which would be 4 squared, which would be 16. Okay. So bases were the same. We kept the base. We subtracted those exponents to simplify our answer. All right, and our last property that we're going to look at is power of a quotient. So similar to power of a product, but in parentheses we have a division problem. So once again, very similar to distributive property, we're going to distribute that exponent to everything we have inside of our parentheses, numerator and denominator. So our example, we have 27 divided by 64 raised to the 1/3 power. So we could write this as 27 to the 1/3 divided by 64 to the 1/3. Now we know that 27 to the 1/3 is the cube root of 27, and this would also be the cube root of 64. So the cube root of 27 we know to be 3, and the cube root of 64 we know to be 4. So our final solution there would be 3/4, and that's how you can use properties of exponents even when you have rational exponents.